In this video, we're going to go over simplifying rational expressions. Before we get into the actual meat of the content, I want to just recall the word rational. That refers to a type of number in math, rational numbers, and rational numbers are any numbers that can be expressed as fractions. So when you hear the word rational in math, you can substitute that out for fractions. So here we're going to be simplifying fractional expressions. Now, not just regular old fractions, because there's going to be variables mixed in. For example, things like these. Now, this first one here, we've actually worked with things like this when we are learning our exponent rules. So that won't be anything new, except that now we're calling it simplifying rational expressions. This second guy, even though it looks really similar, it's actually quite a bit different, and simplifying it is more complicated. And what it boils down to is the first one is all factors, and the second one, there are terms. The numerator has separate terms in it, and the denominator has separate terms in it. Because of that, the way you simplify it is very different. This is a very important aspect with simplifying rational expressions. So we'll take a second to review the difference between terms and factors. Factors are the pieces being multiplied, and while this isn't the precise mathematical definition, this is good way to think of it for how we're going to be using it. Factors are the pieces being multiplied, and terms are the pieces being added. So the reason why this is important is because when we're simplifying rational expressions, factors can be canceled and reduced. However, terms, or any part of a term, cannot be canceled nor reduced. And this is a big deal because when we're simplifying a fraction, really all we're doing is reducing things. And so we can only do that when we have factors. When we have terms, we cannot cancel and we cannot reduce. Let's look at some examples to see how this plays out. Alright, let's say we have this rational expression, 4x squared y to the 6 divided by 6x y to the third. Now here, everything in the numerator is being multiplied. That means the numerator is expressed in factored form. Also, everything in the denominator is being multiplied, so that means what we have in the denominator is also being expressed as factors. So we are able to reduce this, and we worked these problems when we were learning our exponent rules. So the 4 and the 6 will reduce like a normal fraction. Those both contain a 2, and so we'll divide that 2 out of them. So those will reduce to a 2 over 3. Now with the x's, this is where we think we have 2 x's on top, we have 1 on bottom. One of the ones on top will cancel with the one on bottom, leaving us with 1x on top. And with the y's, we have 6 y's on top, we have 3 y's on bottom. 3 of those y's on top will cancel off the 3 on bottom. And that leaves us with a y to the third on the top. So here we see our rational expression simplifies to 2x y to the third divided by 3. Now let's look at a rational expression containing terms to see how this is different. Alright, so in our second example we have 2x minus 12 divided by 3x minus 18. Now with this guy, in the numerator we have subtraction, so that means we have terms, and in the denominator we have subtraction, so that means we have terms in the denominator as well. We cannot cancel or reduce anything as long as things are expressed in terms. So for example, I cannot just cancel these x's off. I cannot reduce my 12 and 18 to a 2 and 3. Because the 12 and 18 are terms, well, the negative 12 and negative 18 are terms, and so I can't reduce them, I can't cancel them, or reduce or cancel any part of them. So I can't divide the 6 out of those two. So then the question becomes, what do we do? If we can't cancel anything, what do we do? Well, the key is we can cancel factors. And so In order to convert this to factors, we need to factor anything that can be factored. So if I look at my numerator, that's a polynomial inside the numerator, and that polynomial has a GCF of 2. So I can factor that GCF of 2. That factors as 2 times the quantity x minus 6. Now if I look at my denominator, it has a GCF of 3. And that factors as 3 times the quantity x minus 6. So now that it's factored, it's expressed as factors. So it seems a little weird, but in the numerator we can think of that as 2 times x minus 6. Those are factors. 2 is a factor of that expression, and x minus 6 is a factor of that expression. So I can cancel or reduce those pieces. Similarly, in the denominator, 3 is a factor and the quantity x minus 6 is a factor, so I can cancel or reduce those pieces. In this case, the x minus 6 divided by x minus 6 is a 1, and so those will cancel out, leaving me with 2/3 as my simplified expression. So that's the idea. If the problem we're given is based in terms, so there's addition and subtraction in the numerator or the denominator, we first need to factor anything that can factor. Once we get it in factored form, we can cancel off factors that are the same in the top and the bottom. Let's look at a third example. Alright, let's say we have this guy, x squared minus 3x minus 10, all of that divided by x squared minus 4x minus 12. Now, here the factoring is a little bit more complicated, but we'll just go ahead and get it factored because we know it's in terms. In order to simplify anything, we need to get it expressed as factors. The numerator factors as x minus 5, x plus 2, and the denominator factors as x plus 2, x minus 6. I'll let you verify that factoring on your own. But once we get it factored, then we're looking at things based on factors. Here, we have the same factor x minus 2 in both the numerator and denominator. So those will divide down to a 1, leaving us with the simplified rational expression x minus 5 over x minus 6. And that's done. We are finished. I want to caution you for not, sometimes someone will go through all of this process correctly and then they'll get down here and cancel off their x's. But now that we have reduced x in terms of the numerator is back to being a term. X in the denominator is a term. It was only when we were considering it as a whole that it's a factor of the numerator. But inside that factor are individual terms, and those individual terms inside of that factor cannot be canceled or reduced. So that's the idea of simplifying rational expressions. When you first look at the problem, you decide, is this expressed in factored form or is this expressed based on terms? If it's expressed as factors, you can go ahead and reduce and cancel. If it's expressed based on terms, then you will first need to factor anything that you can factor, and once things are factored, then you can cancel common factors. But at no point can you cancel a term or any part of a term. Go ahead and give some of these a try and see how you fare. I do want to caution you that they are highly dependent on your skills in factoring. So if you're not strong on factoring yet, they can be a bit time consuming, but that doesn't mean you don't understand simplifying rational expressions. That just means you need to practice your factoring more. And these problems will give you plenty of opportunity to practice your factoring.